requires two different formulas. So it actually requires you to know something. Generally, in an exam, they give it to you, but I like to tell my students, you know what, because you know it's always going to be the same thing, you have to memorize them. So the formulas are this. So for type 2, give me a second, guys. There you go. Oh, I am very well, thank you. There you are. No, it's for one of them. Awesome, I'm going to All right. Sorry about that. Okay, so the two formulas that we need to know. Z to the n plus z to the negative n. Well, we're going to prove what this becomes, right? But it becomes 2 cos n theta, and then z to the n minus z to the negative n. That becomes 2i sine n theta. I guess we'll put brackets there so you don't get the n and the n mixed up. So for the second type, you actually need to know these formulas. Again, for the first type, what we did, regardless of if we wanted sine or cos, so let's say this question here, regardless if we wanted this or this, we used both, right? We expand the whole thing. Then depending if we wanted this, depending if we wanted real, we equated real. Depending if we wanted imaginary, we equated imaginary. For these types, it's not like that. Whatever you actually want is the one you choose. So if it's cos, then we'll choose this one on the left. If it's sine, then we'll choose this one on the right. So it's not like the top one where we did it for both of them and then equated. This one, you actually need to know if it's cos, I choose this one. If it's sine, then I have to choose the second version, this one here. So at this point in time, any questions? Let's prove these though for a second. What does z equal to again? What does z equal to usually? There's two forms of them, or three forms really. What can z equal to?
A plus IB.
There's one form, that's Cartesian. Probably not going to use that. Next one.
R cis theta.
Yep, but we're assuming r is equal to 1, so therefore we're just going to say cis theta, and then obviously the other one is EI theta. EI theta works well as well, but because we're dealing with trigs, now we're probably going to avoid that, and we're going to not use that either. So our z equals to cis theta. In fact, whenever you're going to say let z equal to something, if it was in polar form, we kind of can ignore the r. So we assume it's just cos theta plus I sine theta. All right, sub it in. Let's see, left hand side. E equals zn plus z negative n. So cos theta plus I sine theta to the n plus cos theta plus I sine theta to the negative n. Expand using De Morey. What's cos of a negative n theta? What's cos of negative n theta? What's sine of negative n theta? So what do these two become? Cos negative n, sine negative n. In terms of positive and negatives, now that's all I'm talking about. So what should this become? What should this simplify to?
Cos n theta.
Yep, because it's always even, so negatives are still the same as positives. Whereas this guy?
Minus
I sine n theta, and then what happens? Oops. What happens? This and this would cancel out, and you're left with 2 cos n theta. And obviously, if we were subtracting, your causes probably would have cancelled out and your sines would have had 2i sine n theta. I'm sure we can see how to get this one out. So generally, if you memorize the first one, a lot of students actually know the second one almost subconsciously. So imagine a minus sign and then that becomes a plus, that'll become a minus, cancels out. Okay, that's the proof. You need to know the proof. Okay. You need to know the proof. Done. Now, like I said, depending on the question. So this question had causes on your left side. So we're going to choose this one here. Now it might look strange because you guys might be thinking, oh, Sam, but that's a multiple. But that's okay, because remember the answers that we want are going to be multiples anyways. So that's how we're going to bring that in. So here's the tricky part though. Compare this one here, to this. Can somebody tell me what n equals to? This n. This n. And I'm going to say yes, it is a trick question.
6.
Say that again.
Is it 6?
It's not 6.
Oh.
That is a power. That's not a power.
Is it 1?
It is 1. What is n equal to? Well, n is the number in front of theta, so the multiple of theta, n equals to 1. Now, 99.99% of the time, for your first case, n should equal to 1. The only time n is going to be different is when you're doing your right-hand side, this part here. So just be careful so you don't confuse yourself. N equals to 1, which means you're going to start with z to the power of 1 plus z to the power of -1. So now for this question, we're going to start off with z to the power of 1 plus z to the power of -1, which equals to 2 cos theta. But in reality, what power do we want to make this whole thing into? What power now? What power do I need to go and put both sides to?
6.
Now it's going to be power of 6. That's going to be power of 6. So on I'm going to just swap them around because I don't really like this one on the right side. So that's going to be 2 to the 6 cos to the 6 theta. Yay. This one. Look, this is a personal preference, what I'm about to do. I don't like negative indices. The only time I use negative indices is literally this question, just to prove. So, because if I had this as a fraction, you would not have been able to prove this. But as a negative index, I just don't like it. It's a personal preference. So what I do is I change it to a fraction like this. So z plus 1 on z to the 6. And then, obviously, as you see this now, you know we're about to expand it. So 2 to the 6. 2 to the 6 is 64. Equals z6 plus, don't forget your coefficients, 6 choose 1, 6z5, 1 on z, plus 15 choose z4, sorry, 1 on z squared, plus 6 choose 3, 20, z cubed, 1 on z cubed, plus 15 z squared, 1 on z4, plus 6z, 1 on z5, plus 1 on z6. If you're good with your index laws, you don't want to do that, just use your index laws. Don't change. It's okay. Any questions about what I've done there? Let's recap this for a second. Step 1 was we need to know that for this second type of questions, we need 2 different formulas. Yes, you need to know how to prove it, so be ready for that. Step 2. Step 2 is you let n equal to 1 and then take both sides to the power that you wanted. So let n equal to 1. Take both sides to the power you wanted. Then expand, obviously, this one here using binomial. And that's where we're at the moment. I'll let you write it down. Okay. Next line. We have to equate, we have to group. So group, I'm going to maybe, I guess, underline them, right? So Z6 and 1 on Z6. Let's group them. Again, you don't have to do things as fast as I do. Sorry if I go fast. But all I'm about to do is just simple algebra. But if it's confusing you, let me know. That's Z4. That is also Z4 on the denominator. Because I know I want to group them, can you see they both have factors, common factors of 6? So 6 and then Z4 plus 1 on Z4. And then again, Z squared and Z4 is 2. Z squared and Z4 is 2. Common factor of 15. And then Z squared plus 1 on Z squared. And the last one, these guys just cancel out. You're left with plus 20. Any questions, you guys? A little bit weirder than the other one. You can see why. Seriously, any questions? Rav, Julia?
Maybe later we'll have questions.
Sure. And then once I've simplified that bit, you can see that's still not that great because you've got it in terms of z's, but you're meant to get it in terms of causes. But now you know the formula. You know that, you know Zn plus Z negative n is 2 cos n theta, right? So all of these brackets that I've got should be able to simplify. So 64 cos to the 6 equals Z6, right? Using this formula becomes 2 cos 6 theta, because obviously n is equal to 6, plus 6, n now equals to 4, 15, n equals to 2, and then plus 20. And then you're pretty much done. You just divide everything by 64, and you're finished. 1 on 32. 2 divided by 64 is 1 on 32, cos to the 6. If I factorize 2 out, 6 cos 4, factorize 2 out, 15 cos 2, and factorize 2 out, that becomes 10. So all I did there, if you're wondering, is I just took out a 2 from everything, because 2 divided by 64 is 1 out of 32. 1 over 32. And that's it. Pause. Let me exit and shoot with your question.